Why does light look like a tiny bullet in a vacuum, if the vacuum might not be empty at all? In the energy filament theory, light is not a thing flying through nothingness. It's a relay of the same rhythmic disturbance handed from one patch of an invisible energy sea to the next. Start with the base. Empty space between stars is not empty. It is filled with an energy sea you normally cannot see. Like clear water, you only notice when something ripples through it. And a photon is not a little marble. In this picture, when an atom transitions, the outer swirl pattern of the particle spits out a short, twisted filament-like wave packet, a burst with a head and a tail, because the transition happens inside a tiny time window. It is not an endless sine wave. It is more like a tight pulse. Why the twist? Because the emission pattern is not a static nozzle. The outer swirl has orientation and often a small internal rotation. As the burst is produced, the exit angle can sweep slightly, so the emitted filament naturally carries a corkscrew twist. Add the local tension channel around it, which squeezes the disturbance sideways, and you get something that is thin, short, and directional. You call it a wave because rhythms can add and interfere. You call it a particle because the packet has boundaries. Wave-particle duality is just two readings of the same relay process. Now the key moves. After emission, light does not fly like a bullet. It gets copied. Think of a stadium wave. Nobody runs around the stadium. Each person just stands up and sits down in place. But the pattern moves forward. That is what the energy sea does. One region tightens and relaxes in a specific beat. Hands that beat to its neighbors, and the neighbors hands it onward. What you see as a beam is many locations performing the same motion in sequence. This also makes the speed limit intuitive. The speed of light is not a photon's personal running speed. It is the maximum reaction rate of the sea. How fast one patch can hand the beat to the next patch. A tighter sea relays cleaner and faster. A looser sea relays more sluggishly. That relay ceiling locks down causality. No signal and no influence can outrun the sea's best handoff. Light sits near that ceiling because it drags almost no matter with it. It is the sea doing the cleanest possible oscillation. Now, look at what happens when the relay hits matter. It is not just reflection. The packet can be absorbed by a ring structure and converted into internal motion that shows up as heat. Or the structure can rewrite the beat into its own stable rhythm and re-emit it. That's color and scattering. Or the relay can find an easier internal texture path through the material and hand the pattern along to the far side. That's transmission. As long as the beat is not absorbed or scrambled into noise, the relay can travel vast distances, which is why starlight can cross the cosmos. In this picture, light's shape and rhythm are never independent. The shape is set by the source's swirl nozzle geometry and by local tension squeezing the filament into a tight corkscrew packet. The rhythm is set by the source's internal timing and the local state of the sea. And here's the strategic twist tied to the previous episodes. If the sea's relay capacity can change with its tension state, then the locally measured speed of light can remain stable because our clocks and rulers are built from the same environment. The ratio stays self-consistent, even if the deeper relay ability slowly evolves. That means looking back into the early universe with today's fixed sea can invite a misread. You might call it geometric expansion, when part of it could be a changing relay medium and changing yardsticks. Next, we'll sharpen this into a testable question. If light is a relay in a real medium, what specific fingerprints should appear in polarization, interference, and the way beams pass through each other? And what would change near extreme regions like black holes or a silent cavity? Tap follow, share it on New Physics, Clear Universe.